When building data pipeline, it's pretty common that you would like to switch to a different execution engine. Would it be for migration purpose, pointing to another database with the same pipeline, or for efficiency, using lighter framework for one node processing and still being able to use distributed compute like Spark when scaling? And what if you could keep the same code base but change one line to point to a different backend for your execution engine? Well, that's the promise of Ibis, and that's what we are going to talk today. Cody, welcome. You're a product at Voltron Data. What is this company all about? Because I was talking and doing an introduction about Ibis. Can you maybe introduce yourself and how are you linked or not to the Ibis project?
Is a company that formed really out of a few open source companies a few years ago. You can go and kind of read about that history. But they make up some of the main contributors to a lot of the popular open source frameworks and data, namely Apache Arrow, the Ibis project, and Substrate are kind of the big three. So we contribute to those open source projects. We offer enterprise support for all of those open source projects. And then the main product that Voltron Data has is called Theseus, which is a accelerator native GPU big distributed data engine. They also, of course, support the Ibis project, which is the main thing that I focus on, which is a separately governed open source project.
Yeah, so that is interesting. But before diving into the story, can you give us some timeline into Ibis, because it starts to pick up now in terms of traction in the community? I see some people, I've heard it in the comment, but when did it actually start? Is it actually a new project? And how does Voltron Data that involved into that project?
Yeah, that's a very good question. So Ibis is actually almost 10 years old. I think it's 9 years old at this point.
Wow.
It was initially created, it was created in 2015 by Wes McKinney, who is, of course, the creator of Pandas, co-creator of Apache Arrow, and one of the co-founders of Voltron Data. So that is partially how Voltron Data got involved. They, of course, knew about Ibis from Wes. And the other reason why Voltron Data is involved is rather than this kind of trend we see of each database vendor or everyone creating their own DataFrame API for their backend, Voltron Data likes to support these open standards. And if Ibis can grow into that open standard that works with every database backend, then it's just a single API that everyone has to learn. So yeah, the project is quite old. It went dormant, I would say, a few times. And Voltron Data really picked it back up in early 2022, hiring many of the current engineers who are on the team. So it's been getting a lot more traction the past couple of years.
Yeah, no, that's really interesting. You mentioned the other main project from Voltron. I want to touch down on this. Theseus, right? Is that correct?
Yep.
Let me share it the audience. So it is actually basically kind of the first data processing frameworks on GPU. Correct me if I'm wrong. Actually, I haven't heard any of it, so I'm curious.
Yeah, it's not necessarily the first. So many of the founders and people who work at Voltron Data had worked at NVIDIA before on the CUDF project and other things as well. So CUDF is kind of Pandas on GPUs. You can distribute it through Dask. But Theseus is basically a ground-up rewrite or first-time write of a big distributed system that runs on many GPUs. And it's really operating in that Theseus is not for 99% of people. For 99% of people, something like DuckDB or Polars or whatever is probably what you need. But when you get into that 30 plus terabyte range, that's where Theseus kind of comes in.
Yeah, I like you gave already some size bucket, because I think that's the whole philosophy that the data ecosystem is going through. Is that we used to have one mainly data processing framework, right? We started with Hadoop, then distributed it to scale. and then kind of like going down slowly because, single node machine and laptops have been more powerful. But then we are in this situation where we have to kind of embrace different execution engine, right? And maybe maybe it's that premise that when does like actually Ibis dive into this single API approach, and where did that design was triggered from?
Yeah. So that is the premise with Ibis, is that whether I'm working on my laptop or on a BC cloud VM, or with one of these distributed frameworks, whether it's PySpark or Trino or Theseus, I can use the same API and use the same code, whether I'm doing development as like a data scientist or productionizing something in a larger pipeline. Ibis was initially developed as a for Impala, actually. Impala is a little less popular these days, but that was kind of the first.
Came back to a couple of years ago.
Yep. So it started with Impala, then I think the Postgres backend got added, and SQLite, and more backends over time. So now we're up to over 20 backends. Whichever backend you choose, whichever one's the right tool for your size of data, whatever job you have, you can use them all using a single API.
Yeah. So I have actually here one of your slide, kind of a history, right? That where just the data frame history ecosystem, because I feel it's super interesting that Pandas was first, and actually Pandas was inspired by the R programming language in this data frame approach. They were first. And then we had Spark, Dask Dplyr, Ibis, then QDF, so Pandas and GPU. But this is actually, I never seen that much use case on this one. Is it because, why do you think it's because like it's mostly a specific GPU that you need to be able to run those?
Yeah, you need NVIDIA GPUs. They only work on NVIDIA. Some people have those on their laptop, but it can also be hard to set up, and you can run into memory issues. Like until kind of recently, GPUs have not had many gigabytes of RAM. So it's very fast if it works for what you're doing, but it can be a bit more cumbersome to set up and easier to hit out of memory issues.
Yeah. And then we had Modin. That's on that's been acquired, right? I think so.
So Modin is an open source project, still lives on. The company Ponder, which offered Modin on top of certain database providers, was acquired by Snowflake.
That's correct. Then Koalas, which has Pandas on Spark. I'm wondering where it is right now, because I feel, a lot of like I've seen Databricks invested a lot into PySpark, just that.
Yeah.
And I feel with the other competitors that we're gonna see that it's just getting more. Then we have Polars, which is multi-core data frame in Python via Rust. So Ibis. So this is where the API journey started, or earlier. Is that correct, roughly?
So it's been around since 2015, but really in 2022 is when the much of the current team that works on Voltron data was brought on, started working on it full time, and you can see in like the commit history and everything else, that's really where the project took off.
And then you mentioned Snowpark Python, which is again another different things, and BigQuery data frame. Pun on Google. So they are using Ibis? Is that correct?
Yeah. This one's interesting. So one of the points of this slide is, with Ibis, we kind of run into the classic standards problem of, okay, there's 14 different data frame libraries, and Ibis is trying to be one to unify them all. We kind of see a few different approaches that many of these take. Like many of these are pandas on X. But we kind of believe that pandas is not really the right API for distributed computing, and there's a lot of baggage with pandas, which, to their credit, they're doing a lot of good work to make pandas faster and integrate Apache Arrow and a bunch of good stuff there. But the last one is a very cool example because BigQuery wanted to build a pandas on Google BigQuery, and rather than start from scratch and do everything on their own, they instead actually wrap Ibis and basically provide the pandas API, which goes to the Ibis API, which then goes to BigQuery SQL. So yeah.
So there is a bit of a round trip.
Yep.
There, I guess. Yeah. No, but that's interesting to see, and next to that, we have basically kind of like three approach. If we summarize, in the data framework, right? The pandas clones, as you mentioned, PySpark clone, and something else. But there is also a rise of SQL, right? Lately.
Yep.
And I think it is mostly. Why is that? Why is that so? Do you have some thoughts on that?
So SQL, in theory, is a standard. There is an ANSI standard for SQL, but in practice, every database has their own dialect of SQL, and it's not really the fault of these people. Like DuckDB calls it friendlier SQL, and like they get a lot of requests from customers and users, and people want this and that, and they add them to their own dialects. But that brings us to an issue of it's then hard to kind of go between different SQL dialects. And there are also good open source tools popping up for that, like SQLbot, which Ibis uses fairly heavily. The other thing, I very much come from this data frame world. I've worked primarily with data scientists and machine learning engineers before. Then I hopped over for a little while to DBT Labs, which is, of course, very SQL heavy. And I kind of got to see this other side of like people who perhaps kind of like you said at the beginning, like really don't like data frames and just want to sit in SQL and in that terminal. So there's very much two different worlds of like Python data frame people and people who just prefer SQL. And kind of in both of them, you run into dialect issues or API issues where there's one data frame for every database, for every query engine, and maybe one SQL dialect for everyone as well. So unifying those is a very cool promise that Ibis tries to do, at least on the Python side.
Yeah. And it's so you point out that SQL is, there is an NC norm SQL, but this one is, evolving not enough fast than the industry needs. And I think that's why every single database build their own, function. I think recently there was some JSON features added last year, but like for 7 years, there wasn't any updates. And if you feel like 7 years in the data world, it's like, more than a decade with everything that happens. So there is definitely that. But I feel like your journey is actually, kind of like synonym of the SQL rise, where DBT, enable to lower the technical barrier to entry. So you don't need to know Python, and you just run SQL. But initial pipeline, distributed pipeline, we're writing in Spark and Scala Spark, and that was like heavy, data frame approach. But it's interesting to see that basically we started with data frame, we turned to SQL, and now we kind of like seeing, the rise of like data frame library again with like Polars and others and Ibis, right? So it's kind of full circle. When do you think so maybe, we can dive just a quick, there is a slide I want to show, two slides I want to show. There is this one, and there is the phone, have pink. This one, is basically show directly, the added value of Ibis, that you write a single, in a single syntax, and then you can use a different backend. Would it be BigQuery, ClickHouse? So there is a bunch of them here on the SQL side. And then there is still data frame, pandas, polars. And I think PySpark. PySpark is over there to see.
Yeah, we actually used to use the PySpark DataFrame API, but recently switched over to using SQL directly, which makes it a little easier to manage.
Yeah, I guess so. And Databricks have been also invested a lot on their SQL interface. I think to the extent that we just say a lot of people are using SQL too. And so then there is this slide that I really like because it shows basically in one picture what Ibis does. Congrats on that. I don't know if you're the author of this slide. But if you want to run DuckDB as a backend, this is basically how you do it. You get your data frame and you can do a group by. If you do polars, if you want to use polars, this is how you do it. And actually, as you see, if I change, there is just the first line, which is changing, right? Can you a bit elaborate on how this works?
Yep. So that is the ideal, is that to change your backend and going from DuckDB to polars to Data Fusion, or DuckDB locally to Mother Duck remotely, or PySpark remotely to or locally to remotely. All you change is basically your connection there and your connection string. This is just showing local backends because it's a pain to set them up for Snowflake and all these other things in these slides here. But yeah, you just change your connection out, and then the API is the same, and what you get out of the backend is the same. There are, of course, edge cases and like how different backends handle regular expressions and a bunch of different considerations. But for the most part, Ibis does a pretty good job of making the experience and the code that you get, the SQL code in particular that you get out of them, uniform across backends.
Yeah. Related to the different backend and the development, we have an interesting question from Christian here. So how does Ibis feel about focusing development to creating and maintaining connectors for many backends compared to trying to accelerate adoption of Arrow, Data Fusion, Substrate? So Ibis just maintains to one connection and push the backend connector to the Data Fusion or Substrate level. Does that make sense? So basically, I think the question what's it adds another layer for you to maintain. So how do you what pro and cons do you see today into that?
Yep. Maintaining many backends is definitely a big technical challenge. One of the so there are a few things that make this easier. One are these kind of standards. So Apache Arrow as a memory format standard, we can typically pass data between the backend and the client. Or even between backends through Apache Arrow. Less mature, but promising in the future is like the Apache database connectivity, ADDC. ADDC. So if every backend supports that in the future, then Ibis can just connect through ADDC and have these standard connections. Right now, I use the DB APIs for the most part for most of these things. So we want to kind of, as Voltron Data and also as the Ibis project, we want to increase the adoption of these standards that make Ibis's life easier and ideally everyone's life easier. Substrate is another good one. So Substrate would kind of replace, not necessarily replace SQL, but act as an intermediary representation so that Ibis or SQL or any other of these frameworks could compile down to Substrate. Send that to the backend, and that would help alleviate some of the SQL dialect management that Ibis currently has to do.
I'm familiar with Arrow, but I think it's important maybe we give just a little bit of perspective. Some people who hasn't heard of Arrow, because I feel it's always the hero unseen. It starts to be everywhere now. So if you can get like a bit of like context of what Arrow is.
Sure. Apache Arrow is a another open source project under the governance of Apache. It was co-created by Wes McKinney as well as other people. Many people will try and data work on it. And basically, it's a standard for specification for in-memory data. So it's what DuckDB uses, what Polars uses, what Velox uses, what Theseus uses. what a lot of engines have started to use as their way of representing data that's held in memory. So it's, how do you represent an integer or an unsigned integer in 64, floats, decimals, strings, all of those things. And back in the day when this was getting created, every system kind of had their own way that all were very similar for performance reasons, but not quite the same. And yeah, really in the past few years, Apache Arrow has blown up. It's everywhere. PyArrow is, I think, one of the 50 most downloaded Python packages these days, which is quite impressive. Yeah. It's used pretty much everywhere. So it's not really something that most end users of data tools need to worry about. But it is something if you're developing a database or, kind of looking at data formats, is something you definitely need to be aware of.
Yeah, no, that's a pretty good summary. I think that's also like if people are comfortable with DuckDB, that's what enables to convert back and forth between a DuckDB table to a Panda data frame or Polar's data frame without too much cost and without any almost overhead on the compute. And just to give you an example, before you could, I'm not sure what's the status because I'm a bit rusty on Spark, but you could also convert Spark data frame to Pandas since a couple of years. But there was this work of mapping internally to a Panda data frame, which is, I believe, not happening right now. Everything is through Arrow, so it's much, much faster and much efficient. So as you said, it's really great for the community to adopt those standards. I'm really glad that a company like you, Voltron Data, is supporting that because it makes every single end user, life easier if they want to switch to different engine or different data frame, but also vendors or, new library to integrate more easily. I guess it would have been much more also a challenge for you, right? To integrate so many backend, I guess, without Arrow.
Yep. Arrow definitely plays a big part. SQLbot, which is a open source library for cross SQL dialect translation. It's a lot of words, but it makes it it makes our job a lot easier, managing all these different SQL backends. And yeah, also just a lot of hard work from the engineers over the years, stringing all this together and making it all work.
Yeah. This is the project you were mentioning, right?
Yeah.
SQL Glot, which is a SQL parser and transpiler. Because as we just mentioned, a lot of database, there is a SQL standard, but a lot of database doesn't respect that because mostly they build, nice function. I'm using them a lot in DuckDB because it makes just your life as a developer easier. But the count of that is that they don't speak the same function on other database. I want to let's dive a bit into because time is running, Sierra. But I want to discuss a bit around, of course, DuckDB and why actually did you choose DuckDB as a default backend for Ibis?
Yep. I will also Slack you a blog post on this. So we, Philip Cloud, the lead developer, wrote up a nice blog post on this a few months back. But essentially, at some point, Ibis supported many different backends, including DuckDB, but did not have a default. And that kind of added an extra layer of difficulty to get started with Ibis. Out of the box, you have to create a connection. You have to think about what backend you're using. And until you do that, you can't just read CSV or read Parquet files and do all the things you want to do. So DuckDB kind of came onto the scene as this embeddable OLAP query engine that's very fast, very simple, very easy to use and pip install. A backend got added for it into Ibis, and the team and Philip, I think at the time, decided to make it the default, which just makes it that much easier to get started. So Once that was the default, you can basically use Ibis like pandas or any other Python data frame library without even really thinking about what backend you're using, and it'll just be fast and efficient by default using DuckDB. So yeah.
This is the this is the blog that's pretty
Yep.
a good story. I think yeah, you have those distributed compute framework, but it's a bit hard to set it up right for someone to get up to speed when discovering the tool. So that's what you mentioned, and here basically Pandas has been there for a while, and SQLite, but SQLite is not suitable for analytics. And so the fun fact is that we start to see actually a lot of people having. So you're embracing the DuckDB, as a default backend within your product, but there is also actually a lot of product now getting started with DuckDB, because they're getting started rely on a database server, cloud data warehouse. So to namely, we're discussing about DBT. They're getting started is using DuckDB because you don't need to set up, anything in the cloud to get started with DBT. And there is other tools. Would it be data quality or whatsoever? If you want to have, a quick getting started tutorial, it's true that you just do a pip install and you're ready to go. And so regarding DuckDB and Ibis, I've seen also something else regarding the benchmarks. You have another blog. Let me just quickly open this one, where I see you've done some performance here with Ibis plus something else. Can you give your thoughts about this here? And I think this is also really interesting. Those two lines for me.
Yeah. So this was a workload that Philip Cloud was analyzing, I think, PyPI data, and he was doing a lot of string processing in here. The code should be somewhere in this blog. And he found that for this workload in particular, it was like 10 times faster running on DuckDB. I wouldn't take away necessarily, of course, that DuckDB is 10 times faster than Polars. It was 10 times faster for this specific workload. And part of what this demonstrates is that, number one, it's very hard to do benchmarks. They're very workload dependent, and, you can run TPCH queries, and there's like standard things that people do. They're fairly easy to, I don't want to say game, but like make your tool look better. So you really need to analyze yourself and see what works for you. And that's also one of the things Ibis makes easy. If you want to run a benchmark on DuckDB and Polars and Data Fusion and whatever else, you can just write your code once, switch your backend connection, and see what works best for you. This blog also led to, I think, quite a few performance reports. I know an issue was opened in Data Fusion. I think one was opened in Polars for this. So I'm guessing if we reran it, it would probably be faster for both of those as well. It just demonstrated that at the time, for what Philip was trying to do, this workload ran nice and smooth on DuckDB, and much worse performance on the other two of the other backends that he tried out.
I want to learn that taking a lot of precautions and caution regarding benchmark. It's funny because we talked about that during the last quarter code. You mentioned TPCH, which is a benchmark analytics, and it's really a lot of matter of benchmark, and exactly said it. You can game it. So do your own research, and it's depending on the workload. But all of that to say, I think what is really interesting for me, even more to what you said to an extent, is that you actually don't have any overhead, apparently, compared to Polar's native. Where would you see specific overhead of Ibis versus Polar native?
Yeah. Yeah, it actually shows that it's faster, which I'm guessing that's just due to variation. But basically, for any real larger data size you're running on, you're going to see effectively no overhead from Ibis. It's not zero, of course, right? Ibis is you have to load in things in Python, and Ibis does a little bit of computation or compiling of your expressions. But most of the time, for most data workloads, is really spent on transforming the data, running that SQL code or Polar's data frame code in their case. So yeah, Ibis with very minimal overhead basically allows you to interface with your backend without taking any sort of performance hit. Um, there are of course edge cases and bugs that come up, but we're pretty good about fixing those if they get reported to us.
Yeah. No, but that's great. So where do you see basically the usage patterns popping up when using Ibis today? What's the common use case within a people? I'm having already my data stack. What's the common thing that you see repeating at your current users?
Yeah, we see a few things. One is just the basic kind of analytics or data science case where you do have to work with more than one backend. So like for an organization that's using Panda, or their data scientists are using Pandas locally, and then you're trying to rewrite that into PySpark or SQL to deploy it. That's a pretty good use case. We're seeing some more adoption from library developers. So like the Google big frames that we saw. If you wanted to build a Pandas clone for your database today, I think that the work they've done there in open source and just in general using Ibis, you're probably going to have a better time than trying to start from zero and doing it all yourself. So we see those kind of library developers. And then we also see people who like to mix and match SQL. This was an interesting quote from a user that was like, I like that I can just run my SQL strings through Ibis and use that when I'm familiar with SQL. But if I want to do something more complicated or something that's better to express in a data frame syntax, you can just use the native Ibis data frame code. So yeah, a few different use cases, but yeah, those are some of them.
Yeah, no, it's really nice to have this being, as you mentioned. I haven't thought about those databases that want to have a data frame interface, but that makes sense. I mean, BigQuery have that for years now, and I think as soon as you want to have more like ETL pipelines, a lot of people are using Python, and so a data frame approach it's easier. But this is something we haven't touched on, and after that, we might go in the getting started for thing. But I'm curious, what is your view on? We mentioned a bit data frame versus SQL regarding adoption. But other than that, why someone to use a data frame approach for a data pipeline instead of SQL?
I would personally recommend it all of the time. I'm not a huge fan of SQL, but there are of course pros and cons, and a lot of it will come down to, I think, just individual preference. What data frames give you though, and really Python, is we kind of talked about DBT earlier, lowering that bar to following software engineering best practices. Python kind of gives you that on another level where you can just test your code or unit test your code with PyTest. You can leverage a lot of the frameworks that are out there already. So if you're trying to do something very complex or more repetitive, you need to use for loops. You need to use these kind of general programming constructs. That's, I think, where Python and a data frame library is quite useful over just plain SQL.
Yeah. So SQL is a structured language. It's not a general programming language. And as you mentioned, there is a limitation to its language, and also all the testing. I think the huge adoption of SQL recently, and that's one of the release and focus on DBT, by the way, these days, is on DBT tests, because people tend to skip tests because it's actually harder to write. I believe tests. It's with SQL. if you don't have like a framework around it, like DBT, for example. But yeah, when you mention if you're using Python or another programming language for the data frame approach, you can basically reuse your testing library like PyTest, and that makes the thing easier. I feel as so, but that some people would argue readability. I think it's just because it remembers me the times of PySpark in Scala, but I think I mentioned I'm just in the same blog. See this, for example. So chaining those operations, I feel it's easier to operate it than in SQL. But again, I think that's mostly a matter of preference. But then again, you have, if you are in an IDE also, you have an autocomplete on specific function and other information on the given method, which is harder. I'm not sure if it's even possible in SQL. You may have like your AI friend in Copilot, for example, but it's just a suggestion. But yeah, that's definitely easier testing and just developer workflow, but it's also a matter of preference. And for that, I suggest we have 20 minutes to go into the getting started. So I actually have a notebook here, a simple notebook that I'm gonna just run the installation again, because it's been just a while. So you install Ibis like this, and I guess this is the optional for the backend and other things.
Yep. So there are a few options. Generally, all the backends are their own options. So DuckDB there. Examples allows you to use the built-in example data. So that installs a couple libraries that you use for that. And there's also like an option for Delta Lake tables. Probably a few other things I'm forgetting as well. Generally, each backend is its own optional install.
Yeah. Cool. So depending on the backend that you want, here we'll use DuckDB because it's easier to set up. And the point is, like, this is what we saw earlier. Here we create a table. We picked an example from, it's a dataset, Penguins dataset.
Yep. We like showing that one a lot.
And what is the fetch? I think it's because it's a lazy.
Yeah. So fetch would actually get you the Ibis table from that Penguins dataset. And then to_PyArrow is just, I'm not sure if that's always needed, but I tend to add it onto my create table statements, and that just ensures that it works. Yeah, and that will create the Penguins table in the penguins.ddb file that you have on disk there.
So now if I look my file here, I have a penguins.ddb, and so this is a file, a database file for DuckDB, which is persisted because DuckDB ran in memory. So if you don't persist data to any file, your data is lost after the process. So here is basically just persisting this. I think I really like that in one line you get sample data set. So great job on that. I think it's too overlooked sometimes when you have a getting started. They show some data. I think it's nice to have proper data set to just start it. So congrats to the team on that. Then here we are listing the tables, which are in DuckDB, right?
Yep. So you get the Penguins table, which is the table on disk, and then the Pyro mem table is, I believe, a temp table, or maybe a view. So yeah, if you actually if you were to reconnect, I don't think you would see the mem table persisting. But yeah.
And so here I'm just calling the table and putting this, and then here we are displaying it and converted to pandas.
Yep. So all Ibis.
Yeah. Go ahead.
all Ibis tables have this two pandas method, two Pyro, and also two polars, which was a recent addition. So you can convert to any three of those and do whatever you want with them. Um, yep.
So two polars like this.
Yep. Assuming you're on the latest version.
I think.
Are you on 9.0?
Yeah,
Cool.
let's try it. I mean, let's try it. That's the goal.
Why not?
Maybe there is something missing on the backend, on the option.
It should be there. Although you would need to install polars as well, but the method should be there regardless of whether polars is installed.
Okay, so basically here, we'll look into that if we to install, but so pandas is definitely built in.
Pandas should definitely be there, yeah.
And there, can you talk to us about that? What is it all about?
Yep. So Ibis is lazy by default. If you run expressions, like if you were to run head up there without the two pandas, nothing would happen. And you can chain your expressions and do all that stuff. Interactive basically kind of eagerly gets you the output of the expressions that you're running. So typically you'll turn on interactive, and yeah, you'll see stuff like this, which is representing what you're going to do with the data. Typically you'll turn on interactive mode to do EDA or any kind of notebook local development, and then turn it off if you're putting stuff into production. And then,
I think I want to insist on that because I've seen a couple of, no matter the framework, so lazy, a data processing framework only compute when you request it. And especially in distributed compute, if you, fetch the data, basically you kind of like go against the framework of distributing the data and fetch everything into a single node just to display it. So you need to be careful with that. And exactly as you said, if you're like in a debug mode or exploratory mode, that's totally fine. In a notebook node, that's what we do here basically with this option. And then if I run this option and I rerun, give me the data frame, right? So basically, this is not needed anymore, and it's fetching every time. Be careful. With power comes great responsibility.
Yep.
And then here there is just a simple transformation. Can you write? Can you tell us a bit, like, how did you decide on the different, typical transformation function for the Ibis API?
Yeah. I did not make these decisions, but it's generally inspired by pandas, of course. Like I mentioned, Wes McKinney created pandas and then created Ibis. So some of it definitely comes from that and learnings from what didn't work well in pandas. Then over the years, a lot of inspiration is actually taken from R and the dplyr library. We find that, the R people actually really have very good ideas, and we like to steal them and bring them into Python so that more people can enjoy them. So like there's a relocate method, which will shift which columns are shown at the beginning of your table. That is taken directly from dplyr. And then SQL as well. So kind of pandas and SQL and R are the inspiration for the syntax that we have here.
That's really impressive that you give back credits to our people. I don't hear that often, and I think because it's true that history has shown that the data frame concept were coming from them. And I think it's a really good summary saying that we steal their idea to put it in Python so that more people can access it.
Yes,
that's an interesting message. So this is basically just a simple result transformation. You get the result here after. Now what I want to do is go to maybe you're getting started guy, and go for we've done like quickly this one, right? And you have 3 flavors. Why is that so?
These are intended if you're coming from one of those other frameworks. So dplyr, that was written by somebody who is I'm not going to be able to recall their name, but they know R and dplyr very well. And I will get made fun of for not remembering this, but that's a very good guide if you're coming from dplyr. The pandas guide was actually written by I'm not going to remember his name either, but he contributed the single store backend. I don't know who wrote the SQL one. But yeah, these are intended for if you're coming from those and you're trying to learn Ibis for the first time, this should kind of be a good reference for you of how do I think about, like filtering, sorting, limit and offset, joins, how do I map all this? And I'm actually in the process of working on a PySpark and a Polars guide here as well. So look out for those soon.
Yeah. And is it possible to some extent to put some SQL query, or do you is there actually a method to send directly a SQL query to the backend?
Yep. If you go to I think our homepage, you'll see it on there. If you click over there and scroll down a bit, and I think it's toward the bottom. Right there. So you can actually get the SQL out of your expressions. And there's a table.sql method. The .sql method is also on the backend connection. You can just put in SQL strings, either read them in from files or write them directly, or use Python like formatting, or even Jinja, of course. Get your SQL string and just put it right into your table. And then it's cool that you can chain that directly into a DataFrame code as well.
Here you're basically kind of mixing the things.
Yep.
Select account, and then the order by, which is calling from the API. How do you see people usually working with Ibis if they have SQL code base and going to DataFrame? Do they do this and then refactor by step, or what do you see exactly in the usage portion? Because there is kind of a refactoring step, right?
There is a highly experimental way of actually parsing SQL directly into Ibis expressions. So you can take this SQL and get back code. That's not super working, and I don't think we have it documented anywhere, which is probably good. But in the future, hopefully it's something that we can kind of automatically do for people who want to refactor. But this is always an option if you have some gnarly SQL string, or the other way this gets used is basically as a escape hatch. If there's really something Ibis doesn't support, or that you just don't know how to express, you can always kind of run this SQL if you want and get your Ibis table out and then switch back to Ibis code. In general, you're going to have to refactor your code at some point, and the promise of Ibis is it should be the last refactor you have to do, because it'll just work on every backend that you need.
So we have one of your folks in the chat, DPMan. I hope I'm pronouncing that's right. So from Voltron, which mentioned that we do not have the latest version. I need to restart their session. So if I do an upgrade here, we should be able to do 2 polars, which was part of the latest release 0.9.
9.0. Yep.
9.0 release. So thank you for that. I just put it there, and we'll try it later. But to come back, so I think what's so this is great. I'm curious. Please ping me when you have something like that to put your SQL code into DataFrame code. Would be neat. I think also this is fairly easy to start refactoring step by step. From coming back from SQL. We have a couple of minutes left, and there is a topic, a bonus topic I want to talk about, which is WASM and your let me search that for a moment. Ta-da-dum. So your REPL in JupyterLite in the browser.
Yep.
So I'm running on Brave, so hopefully there won't be any bug because typically those kind of things on Brave doesn't look good.
Oh boy.
But can you? So this is really heavily experimental, but I just want to kind of like, hand up with a bit of a dream. Can you give some context around WASM and Biodins projects and how those came to life? Basically, having Python in my browser running. So this is not running on the server side, right?
Yep. This is running in your browser. I am far from a WASM expert, but I will do my best. So yeah, WebAssembly is a way of basically running code in your browser. The Pyodide project is a project to run Python in your browser. And then part of the Pyodide project is getting various packages working. So like Pandas is in here, Matplotlib is in here. What else? The biggest blocker for us was actually Arrow in the browser. So we were really following along with a community member who was working to get that in Pyodide. It got added pretty recently, and that was the last thing keeping us from putting Ibis in the browser. So we did that, and yeah, highly experimental. This will like crash on iOS. I'm very happy that it worked on your browser here, but yeah, it's a really cool way to try out Ibis or other things for the first time. You don't need to have a Python environment. You don't need to pip install anything. You're just kind of in here and you can play around with it. And ideally, we want to like put this side by side next to the tutorial so that you can just like copy and paste and follow along, and a bunch of cool stuff we can do with this. But yeah.
So we've been also exploring exactly the same thing for DuckDB. And I think also having, an easy way for people to getting started. I mean, notebooks are nice, but you're still, relying on the server, and we are not leveraging our expensive MacBook, at least me enough, right? So this is really a nice thing that we start to see more thing, and this is Python. So we could, with the things growing, could even train model locally with just an URL and have your full environment ready. And this is just leveraging your local compute. So this is and if you want to see other WASM, in this case we have on our channel, some on YouTube channel, we have some, if you type WASM, you can see, that little WASM. That train too, so we'll also to see that more in a moment. The project that you end-to-end project regarding analytics of Ibis. So this is the app, and I'll share the repo on the chat so that you have it if you want to have a look. So let's look first at the app. Can you tell us a bit what is it exactly?
Yep. So this is a Streamlit dashboard. All of the ETL and code that's running here on the dashboard is basically Ibis code. And I, as the product manager for the Ibis team, kind of use this to keep an eye on a lot of our vanity metrics. How many stars do we have? How many downloads do we have? Who's visiting? How many people are visiting the docs? How many backends do we have? Yeah, all of this is running. There's basically a cron job that runs DuckDB on a server. All the data gets transformed, uploaded to MotherDuck, and this dashboard is running in real time off of MotherDuck. So like if you change the number of days there, it's like interactive. So you can select some things and the code will rerun and query stuff on MotherDuck through DuckDB and update the dashboard. So yeah, this was a cool like end-to-end project for me to learned a bunch of different tools, and yeah,
Yeah,
runs pretty well.
That's pretty nice. I need to build the same, but so just to say, so when I'm running something here, what it's happening is actually running a query against mother ducks and get it back. It's actually pretty fast.
Yeah, we are looking to do a bunch of things. Some of it's going to be a little boring. So basically working to stabilize the backend APIs for Ibis, really all of the APIs, so that we can have a better foundation for more external contributors. So like I mentioned, Ibis project is it's not owned by Voltron Data. It's a self-governed open source project. And we would love to be in a place where database vendors and whoever kind of choose Ibis as their data frame interface. So working to make the APIs stable and where a company can just come in and maintain their own backend in their own repo is going to be a great next step. But otherwise, we're quite community driven. So when people open issues or feature requests or anything else, we tend to address them pretty quickly. We're also working on a Ibis ML framework, which is for data preprocessing, ML preprocessing of data. So, pandas is kind of what people use, but what if you could just use DuckDB or Polars or Data Fusion or Snowflake and get your data ready to be fed into machine learning models? So yeah, lots coming down the pipe. We're pretty active on our blog, which is a good place to follow along with new things. Exciting future ahead for the Ibis project.
It's pragmatic and technical, so please keep it up. And yeah, I'm curious for the ML or anything. Good use case. People tend to be really dependable on for ML pipeline, so that would be great. Thank you again, Cody, and I'll see you around online because you're traveling.
Yes, I think we're a little far away from each other, but yeah, thanks for having me on, and great to do this with you.